Earth has survived asteroid hits and ice ages, but it also deals with earthquakes that topple cities and storms that flood whole coasts. Our sun will eventually grow huge and make the inner solar system too hot for life. Now picture 4 other planets. They orbit stars built to last 3 times longer than ours. These worlds could have thicker protective air and geological engines that run smoother for billions of extra years. Scientists believe life there might grow bigger, stronger, and more varied than anything Earth has seen. So if one of them really offers a safer long-term home for humans, what stops us from treating it like Plan B? Stick around. The details might surprise you more than the distance. In 2014, Renee Heller and John Armstrong published a paper that flipped the script on habitability. They argued we should look for worlds better than Earth, not just like it. 6 years later, Dirk Schulze-McCouch and a team at Washington State University did exactly that. They studied over 4,000 exoplanets and exoplanet candidates. 24 of them matched the Superhabitable checklist better than our own planet. 4 names keep coming up in that group: KOI 5715.01, Kepler 442b, Kepler 62f, and K272e. Question number 1. With all this promise on paper, why do most people still assume Earth is the best we will ever find? Except reaching any of them is the real problem right now. How can a planet be better for humans if it is hundreds of light years away and we have no way to test its air or soil? The answer starts with the stars these planets orbit. KOI 5715.01, Kepler 442b, and Kepler 62f all circle K-type orange dwarf stars. These stars are smaller and cooler than the Sun. They produce steadier light with fewer dangerous flares. Most important, they can live 30 billion years or longer. Our Sun is already 4.6 billion years old and has roughly 5 billion left before it swells. That extra 25 billion years on a K-star world gives life extra time to develop. It gives any future human colony extra time to grow without racing a dying star. Think about that. Civilizations could rise, fall, and rise again many times over before the star even notices. Why does that long stellar lifetime change the math for human survival so much? Next comes the planet's size and what it does to the ground and sky. These are super-Earths. Kepler 442b is about 1.34 times Earth's radius, with roughly 2.3 times the mass. Kepler 62f is 1.41 times wider. KOI 5715.01 may be close to 2 times wider. The extra mass and size create stronger gravity. Stronger gravity holds a thicker atmosphere in place. That thicker air can shield the surface from cosmic rays and solar particles better than Earth's thinner shield in some spots. It can also create a stronger greenhouse effect that keeps the whole planet warmer and wetter in the right zones. Inside the planet, extra heat from formation and radioactive decay keeps the mantle moving. Plate tectonics stay active longer. That movement builds mountains, opens ocean basins, and recycles gases between air and rock. Earth's own tectonics may be slowing as it cools. These bigger worlds might keep that engine running for extra billions of years. K272e brings a different but still promising picture. Discovered in 2016, it sits only about 180 light-years away in Aquarius. It is roughly 15% larger than Earth. Models suggest it could have a large ocean covering much of the surface. Its star appears to bathe it in gentler radiation than many red dwarf systems. Scientists believe this combination could support abundant marine life and maybe even simple land ecosystems if shallow seas exist. But that's not even the strange part. We have almost no data on what these atmospheres actually contain. Higher gravity sounds good for holding air, yet it would also make every step feel heavier. A person used to Earth might tire faster and face long-term health effects on bones and heart. Some climate models for the outer habitable zone planets like Kepler 62f suggest they might need very high carbon dioxide levels to stay warm enough. That could mean toxic air for us even if liquid water exists. And we still do not know if any have magnetic fields strong enough to protect that air from being stripped away over time. Zoom out, and the picture gets even bigger. Earth is one world with one star's timeline. If even one of these 4 proves truly superhabitable, humanity gains a genuine second chance. We could become a species that lives on multiple worlds with different clocks and different protections. Future telescopes like the planned Habitable Worlds Observatory could start checking their atmospheres for oxygen, water vapor, and other signs in the coming decades. That data would tell us whether these places are real upgrades or just interesting neighbors we can never reach in time. Either answer changes how we see our own future here. If we found out in the next 10 years that one of these four has everything humans need except distance, whose job would it be to decide whether we try to go or focus everything on protecting Earth instead? Remember those four planets with their long-lived orange stars and the thicker air they might carry. They drift through the night sky right now, their shadows already recorded by Kepler years ago. We still cannot say for certain whether they are better homes or simply different ones. Earth might still win on every count that matters most to us. Or it might not. Which of these four worlds would you vote to study first with the next generation of space telescopes? If this made you think twice about what makes a planet truly home, follow along for more deep looks at the cosmos. Share it with anyone who has ever wondered whether we are alone in having the best real estate in the galaxy.